equal to, okay, well, f of x is equal to 2 if x is even, okay. F of x is equal to minus 2 if x is not even, or if x is odd, okay. The important point to make here is this, is that, okay, so what we have is we have a mapping from z into b, okay. The set z, okay, the set z can be partitioned into even and odd numbers, okay, that's important, yeah, okay. So z can be partitioned into the even integers and also into the odd integers, yeah, okay. So actually the set z is equal to the union, okay, of the even integers, okay, unioned with the odd integers, okay. So actually what we now have is this, is that every value in z is mapped into one of these two conditions, okay. That's the first thing. So we know now that f is one step close to being a function. That's important, okay. And also let's just keep in mind, okay, also what we have is we only ever have a single arrow coming out of these values. We don't ever, you're either even or you're odd, if that makes sense, okay. You're never even and odd, yeah. So we only ever have a single arrow coming out of the values in z into the values in b, albeit b can have multiple arrows coming into it, okay. So if I do this, let's say from an arrow diagram perspective, just looking at this particular example, okay, I'll just make it a little bit bigger, okay, so that we can actually see what's going on under the hood here, okay. So let's just consider the set z, okay. So the set z is something like this. So here's the set z. The set b is something like this here. Here's the set b, okay. Well, b contains the values 2 and minus 2, okay. We have the set z contains the values, let's say 0, 1, 2, 3, and so on and so forth. Minus 1, minus 2, minus 3, minus 4, and so on and so forth. Okay, these are these particular values, okay. Okay, that's the z. And as I said, the values, the integers, can be broken up into two sets, the even integers and the odd integers, okay. So let's have a look at this particular function f. So how does f work? Okay, so the function f, well, depending on your value, okay, if you're odd you go to minus 2, if you're odd. If you're even, you go to 2, okay. So, well, 0, well, maybe we'll come back to 0. Yeah, well, 0 is actually defined to be an even number. An even number is any number divisible by 2, and 0 is divisible by 2, so 0 is even. So that's going to go in there, okay. So 0 goes to 2. Okay, it's even. What about 1? Well, 1 is an odd number, okay, because when we divide it by 2, the remainder is 1, so it's odd, so 1 goes to minus 2. What about minus 1? Well, minus 1 is odd as well, because when we divide it by 2, it gives us a remainder of 1, okay, so that goes in here. What about 2? Well, 2 is even, okay, so that goes in, oh, wrong colour, okay, that goes in here. What about minus 2? Well, minus 2 is also even, so that goes in here, okay. What about 3? Well, 3 is odd, so that goes in here. What about minus 3? Well, minus 3 is odd, that goes in here. What about minus 4? Well, that's even, so that goes up here. The key thing here is that every value in the set z is mapped into some value in b, okay, that's important. So actually what we know is now is that f is a function. The question is f surjective, okay? Is f surjective? Well, for f to be surjective, we need to look inside the codomain, okay? So when we look inside the codomain, the question is every value in the codomain, has it got an arrow coming into it? Yeah? Well, every value in the codomain does have an arrow coming into it. So the answer is yes. F is surjective, okay? So it is a surjective function, if that makes sense. Let's have a look at some other functions, okay. Let's maybe what I'll do here is I'll just get some clean paper first of all, okay. So I'll just get some sheets of paper, okay, and let's have a look at some more implementations of functions, I should say, okay. So let's have a look at some more implementations of functions. I'm just going to move these sheets out of the way, okay. So what we're going to do is, let me just have a look at some more functions, okay. So let's say we define another function, okay. Let's say, for argument's sake, okay, where am I gone here? Where's my pen? Here it is. Let's say we say that let the function, okay. Let's say let the function, okay. Let's say g, okay, be a mapping from the natural numbers, okay, into the integers, okay. defined by the following, defined by the following, let's say, implementation, where we have g of x is equal to, well, it's equal to 9 times x plus 5. Okay, so let that be a particular function, and the question is g surjective? Okay, is the function g surjective? Okay. Well, let's just map it out from a diagram perspective, a narrow diagram perspective, and let's see how we get on. Okay, so we have the set of natural numbers are over here. Okay, so I have the set of natural numbers. That's the domain. Okay, and what we're defining, well, we're suggesting it's the domain, and what we're defining to be, well, it is a function, so it is the domain, and what we're defining is the integers. Okay, is the codomain. So this is the set. This is SZ. And g is a function that goes from here to here. Okay, g is the function that takes natural numbers